I got problem 18.71, which is, yeah. An inflated bicycle inner tube is 2.2 centimeters in diameter and 200 centimeters in circumference. A small leak causes the gauge pressure to decrease from 110 psi to 80 psi on a day when the temperature is 20 degrees Celsius. What mass of air is lost? Assume the air is pure nitrogen. So the air is pure nitrogen, which means that we have to know the molar mass or the of nitrogen for this, which is given to us as 28 grams per mole. Anyways, so here's how we're going to do the problem. So we're finding the mass of air lost, right? Because the air leaked out. So now there's a different amount of air. So first, you're going to list out your variables, right? You're going to change everything to SI units. Diameter goes to, since it's centimeters, 300 meters, and radius get from that too. Circumference is 200 centimeters, 300 meters, 2 meters. Temperature is 20 degrees Celsius. Change that to 303 Kelvin because for every 1 degree Celsius, there's 273 Kelvin. So just add 273 to that, to your to this, and then your PSI. So you're getting the change in PSI, which is 110 PSI minus 80 PSI, which is 30 PSI, and you're going to change that to pascals in the end, and I'll show you that right now. And then we know that our molar mass is 28 grams per mole. And this is what an inner tube is. I looked it up. I had no idea what a bicycle inner tube was. Didn't realize that there was a inner tube inside the bike tire. I don't know why that never occurred to me, but so we're gonna have to find the volume for this, and you can see that volume is the inside the tube. I kind of try to shout out for you, and the pressure is coming from, so it's a gauge pressure, which means that there's something connected to here, and then it's showing how much pressure is. So the pressure is coming from the air inside of the tube, and how much it's pushing out. So then, yeah. Anyways, so then to get to solving the problem, now you have to you look in the textbook, you find out that N is equal to it's equal to mass over molar mass, and then so that means that mass is equal to the N times the molar mass. So how are you going to find N now? So we're going to have to use the ideal gas law, which is PV equals nRT. You rearrange that, you get N is equal to PV over RT, which means that now our mass is equal to N times molar mass is also equal to PV over RT times molar mass and mole. But we don't know the volume, right? Like I said, we need to find the volume of the inner tube. So how much like air can fit in there. And then we see that it is volume is area times circumference, and we know our circumference. To find the area, we need pi r squared, and we have our r, which is 0.011 meters, which means that now everything is equal down here. M is equal to N times molar mass is equal to pressure times area times circumference times molar mass over r and temperature. So now you plug in your values. This is pressure in pascals. That's pressure in pascals. That's your area. That's your circumference. That's your molar mass, 28 grams per mole. This is your R. R is equal to 8.31 joules over like molar K, and then times your Kelvin, which is 303 Kelvin. And then you get all that. It should be equal to about 1.75 grams or like 2 grams for your change in mass of nitrogen. And then down here, can't really see that. Down here, this is how I converted to pascals, because remember that when you do these equations, you have to use pascals for PSI. So you can multiply by 6,900 or 6,895. Yeah. To get like an approximate amount. It's usually a little bit bigger than the more accurate one, which is because he gave us atmospheres. 1 atmosphere is equal to 101 K pascals, which is if you do it using that, then you convert PSI to Pascal to atmospheres to pascals, and that's it. So you just do all that, and you should get around 2 grams. You change anything tricky, not really. I just had to go through the book, find out what N is equal to, use PV, nRT. That's it. Good luck. Have fun. A+.